Hi, everyone. I want to talk to you about goalless problems. This is an introduction to goalless problems. Here's a goalless problem. A 1,200 kilogram car, 1,200 kilogram car is initially traveling at 15 meters per second east, slams on the brakes, and skids to a stop over a distance of 17 meters. There's no question there. I'm not asking you to solve for anything. I'm just giving you a scenario. And your job is to demonstrate all the physics you can. So let's take a look at some of the things I have in the solution. First of all, I sketched some of these graphs. Position time graph for an object moving in the positive direction but slowing down. I sketched a velocity time graph. And I sketched an acceleration time graph. I also recorded some quantitative information on these graphs. And I'll come back to that in a moment. I drew a motion diagram with the acceleration vector. And then I thought, what could I solve for? Well, I wrote down the variables I have, the initial velocity, the final velocity, the displacement. I could solve for acceleration and I can solve for time. So I used my kinematics formulas to solve for the acceleration and another kinematics formula to solve for the time. Okay. What else could I do? I could have found the average velocity. I didn't do that, by the way. So I put this information onto these graphs as well for an extra addition to my goalless solution, right? I sketched the area under the velocity time graph is displacement. The slope of this velocity time graph is the acceleration, which we just found, or I just found. I figured out that it took 2.27 seconds to stop, so I put that time on there. I also figured out that the initial slope is 15 meters per second, right? Because the initial velocity is 15 meters per second. Okay, what else do I have here? So I then I turned my attention to forces, and I drew a free body diagram for the car, and I drew the Newton's third law of force pairs. I drew a force schemata diagram. I added a force vector addition diagram. I figured out what the force of gravity acting on the car is. I figured out what the normal force is, and I explained how I know what the normal force is. Okay. I used Newton's second law to figure out the net force acting on the car. I recognized that there's only one force acting in the horizontal direction, the force of friction. Therefore, the force of friction is that. I figured out what the coefficient of kinetic friction is. Okay, so that's a goalless problem. And this is some of the things you can do given this scenario. Some of the other problems may lend themselves more to just forces and less kinematics. Other ones more towards kinematics, less forces perhaps. You can consider energy here, right? We could calculate how much kinetic energy there was initially, how much energy was lost to heat. That's something that I didn't put into this solution, by the way, but I could have done that. I started to do something with power, but I'm not going to get into that here. In fact, let's just goodbye. Yeah, so goalless problems.